So today we are going to discuss about part 6.1 method declaration, overloading and Varargs. So method declaration in Java follows a specific structure. It begins with the access modifier followed by optional modifiers such as static or final. After the modifier comes the return type and then method name and parameter list. Java, it allows some flexibility in the order of modifiers. For example, both public static void and static public void compile successfully. However, all modifiers must appear before the return type. Okay, so valid modifiers before return type is public static void print hello, private final int get count return 0, then final static void jump. This is the order among modifiers is flexible. Okay, final static void jump, that's order among modifiers is flexible. So writing something like void final method is a compile time error because the return type appears before the modifier. Return type must not appear before the modifier. A method can only have one return type. Okay, so declaring something like public final int void method is invalid since Java does not allow multiple return types. For void methods, you can use a simple return statement to exit the method early. Okay, so this is often used in guard clauses to stop execution when certain conditions are met. However, you cannot return a value such as null from a valid method. Okay, so void methods empty return is okay, return null is not okay. Okay, so like you have void display if done return early exit, that is valid, but return null, it will be a compile error. Void cannot return a null. For non-void methods, the value return must be assignment compatible with the declared return type. Okay, for example, returning 9.0 from a method declared to return int will cause a compile time error because Java does not automatically narrow a double to an int. Okay, so method overloading, same name and different parameters. So what overloading is, right? So overloading means having multiple methods with the same name in the same class as long as their parameter lists are different. The compiler looks at the arguments you pass and decides which version to call at compile time. Okay, so valid overloads like void process intx, void process $x, void process intx, inty, void process $x, inty. Okay, so all four of these are valid overloads of process method. Okay, the first two differ by parameter type, int versus double. Third differs by parameter count, 2 parameters instead of 1, and 4 differs by parameter order, double first and then int. Any difference in the parameter list like type, count or order, it creates a valid overload. The compiler can distinguish between them. Return type does not create an overload. Okay, so if you have int get value, then return 1, I void get value, so it will be a compiler error because these two methods have identical names and identical parameter lists, but both take no arguments. However, the only difference is the return type. That is not enough. The compiler determines which method to call based on the arguments passed, and since neither method takes any argument, and the compiler cannot tell them apart at the call side. So this is a duplicate method declaration. It will lead to compiler error. The return type is completely invisible to the overload resolution process. You cannot overload on return type alone. And then ambiguous call is a tricky one basically. So you have void mate int a long b and void mate long a int b, and then you're calling mate 5.5, right? Calling the method mate with 5 and 5. So it will be compiler error, ambiguous. Both methods exist and both are valid overloads, but the parameter order is different. But now look at the call, right? Mate 5, 5, both arguments are int literals. Okay, to call the first version, Java would need to widen the second argument from int to long, and to call the second version, Java would need to widen the first argument from int to long. But both require exactly one widening conversion. Okay, so neither is a better match than the other. The fix, so what will happen? The compiler, it will not be able to decide which one you meant, right? It flags this as an ambiguous method call. It will be a compiler error. So fix would be to explicitly tell the compiler which version you want, right? So you have to call it like mate 5, 5 long, or mate 5 long, 5, right? So in that case, the first version 5, 5L will call mate int long, and the second version 5 long, 5, it will call the mate long, int, right? In that case, it will be okay. So the 3 overloading rules you should remember is that the valid overload is different parameter type, count, or order. Any of this is enough, not a valid overload. Not a valid overload, return type alone. Okay, so if you just have a return type, different kind of return type in two methods, everything else being same, so it will not be a valid overload. Okay, so method overloading, determining method to call, right? So the overload resolution priority, right? So this example here, it demonstrates exactly how Java decides which overloaded method to call when multiple options are available, right? So Java, it follows a strict priority order. It does not pick randomly. It always tries the most specific match first and works its way down. The priority is exact match first, then widening, then autoboxing, then Varargs last. Okay, so if you see in step 1, right, it's an exact match. You are saying in public static void main, it is demo new test and int a equal to 10, and then you are calling demo.display a is equal to 10, right? So what happens is that a is an int. Java looks for a method that takes exactly an int. No conversion is needed. It finds display int and calls it immediately. Output is exact match. Java will stop here. It found the best possible match and does not look any further. Okay, so it will not look any further. And then in step 2, widening, if exact match does not exist, right? If display int did not exist, Java would not give up. It would try widening, promoting the int to a larger compatible type. So int can widen to long, float, or double automatically without any data loss. Java would find display long L next, and long is the closest wider type to int, and call that instead. And output would be widening long, right? If display long also did not exist, Java would continue widening and find display double D. Output would be widening double. Widening is always preferred over boxing. Java would rather promote a primitive to than wrap it in an object, right? And step 3 is autoboxing. If no widening match exists, right? So if none of the primitive versions existed, Java would try autoboxing, wrapping the int primitive into an integer object, and look for display integer int obj. So output would be autoboxing. Autoboxing comes after widening in priority, and Java prefers to keep things as primitives as long as possible. Okay, and then step 4 is Varargs absolute. It is the last resort. Okay, if none of the above existed, Java would finally consider display int Varargs. Okay, Varargs is always the lowest priority option. Java only uses it when every other option has been exhausted. The reason Varargs is the last is that it is the most flexible. It can accept any number of ints including 0, right? Because it matches so broadly, Java treats it as a fallback rather than a first choice. Okay, so method overloading, determining method to call. Okay, so what Vararg is? So let's discuss Varargs. Varargs is a short for variable arguments, right? So let the method accept any number of it lets the method accept any number of arguments of the same type, including 0. Instead of writing multiple overloaded versions for 1 argument, 2 arguments, 3 arguments, etc., you write one method that handles all of them. Okay, the syntax and how it works internally is that say you have this method, right? Void print all, and then int 3 dots numbers, right? So that's the Varargs syntax. And then you have system out.println nums.length, and for intn colon nums you keep printing. Okay, so 3 dots after int declare nums as a Varargs parameter. Inside the method, Java treats nums as a regular int array. So you can call nums length, loop over it with an enhanced for loop, access elements by index. Everything you can do with an array. So this is important. The caller sees a flexible number of arguments, but the method body sees a plain array. Okay, so valid calls are like print all 1, then print all 1 2 3, then print all new int 1 2 3. In this case, you are passing a array directly, and then 0 arguments is also perfectly valid, right? Nums becomes an empty array with length 0, not null. 1 argument but multiple one argument, then multiple arguments, all are valid. You can also pass an explicit array, and that also works. Okay, because Varargs and arrays are interchangeable at the call site. We have to remember that Varargs must be last, right? So if you see the call like void long, see the method declaration, void log string level comma int Varargs values, then void log int 3 dots value string label. That is a second one is a compiler error. Varargs must always be the last parameter in the method signature. Okay, the reason is simple. Java needs to know what the fixed parameters end and variable ones begin. The Varargs if they come first, the compiler, if the Varargs come first, then compiler could not tell how many ints belong to values and where label starts. Putting Varargs anywhere except the last is always a compiler error. And we have to also remember that only one Varargs has to be there in a method. So you can have only one Varargs parameter per method. Having two is a compiler error. Okay. For the same reason as before, the compiler cannot determine where one ends and the other begins. So Varargs is lowest priority in overload situation also, like we have discussed. When you call, say you have void show intn and void show Varargs int Varargs n, and then show you call show 5. In that case, you have two options. So it can call exact match with the int, or you can call Varargs show int ... So Java always prefers the exact match. Varargs is the absolute last resort, only chosen when no other overload will match. Okay, this connects back to the priority order we covered: exact match, widening, autoboxing, Varargs. Okay, Varargs is at the bottom at every time. Okay, so this brings us to the practice question. So we can discuss, let's trace each call through the overload resolution priority: exact match first, then widening, then autoboxing, then Varargs last. Okay, the first call is show 5. 5 is an int literal, and Java looks for an exact match. Show int exists, so perfect match, no conversion is needed. Call show int, output is int 5, right? So Varargs show int is ignored, like we discussed. And second call is show 5l. Again, 5l is a long literal. Java looks for an exact match. Is there a show long there? No, it's not there, so exact match will fail. What will happen is widening, right? So can long widen to anything available? Long can widen to float or double. Java finds show double x. Double is a valid wider type for long, and called show double. So output will be double 5.0. Okay, and third call is show 5, 10. So two int arguments there. Java looks for an exact match. Is there a show int? No, exact match is not there. Widening, can two ints widen to match any single parameter version? No. Autoboxing, no, right? And so we have to fall back to Varargs in this case. Show int x can accept any number of ints. Two ints fit perfectly. So Java calls show int Varargs 3 dots. So output is Varargs, right? So complete output will be 5, then int 5, then double 5.0 and Varargs. Okay. So if you want to practice more such questions, you have to go to https://javalearn.clustermicro.com. There we have 1624 practice questions with each having a very detailed explanation. So, and these are timed exams, and we are having 29 full length practice tests there. Okay, and this is a very fully cloud native platform there, and you have approximately 100 free questions, and then a trial period with another few questions, 30 questions. So you can check that out. Okay, thanks for your time.